Welcome back, everybody. The final section here, we're going to talk about sedimentary rocks. Finally, we're going to talk about the fun stuff: rock salt, don't lick it, conglomerates, shale, sandstone, limestone, and chert, and many more. All right, so what is our central question here? We ask, how does this thing called sediment turn into rock? Well, the process here of becoming rock is called lithification. Lith means rock. So we have 3 steps on the way to lithification. We deposit the sediment, like in the last section, and then we compact it, squeeze it together really hard, a lot of pressure, and then we have this process called cementation. So it's like cement. We have to put something in there that can actually glue the grains together. Let's take a look. Okay, so we have our continental shelf, and we have this sediment in it. And we have all these different little grains. If we were to zoom in here, we have water, and then we have these holes in between the grains called pores or pore spaces, just like the pores on your forehead. And the first step here is compaction. So as layers of sediment build up on the shelf, one after another, the weight of the layers presses down and squeezes the water out. And as this water is squeezed out, it leaves behind little traces, little pieces of what were minerals and salts that were dissolved inside the water. So these dissolved compounds, minerals, and salts precipitate out as this sort of glue that holds the grains together in a process called cementation. Okay, so you might remember way back we talked about the different types of sediment. Clastic sediment, like beach sand; biogenic sediment, which is made out of the hard parts of what is once living organisms; and finally chemical sediment. Well, this sets us up for the 3 types of sedimentary rock, and it's the same. Clastic, made out of those little clastic sediments; biogenic, made out of things that were once living or part of living organism; and then finally chemical sedimentary rocks. So what are our clastic sedimentary rocks? Well, let's look over here first. We have our conglomerate with these big round grains; sandstone, kind of gritty, medium-sized grains. They're just barely big enough that you could see them with a naked eye. We have our breccia, which is kind of like a conglomerate, except that the grains are really angular and sharp. And then finally we have shale, which is like mud rock that has been solidified and has these layers in it. So what makes them clastic sedimentary rocks? Well, we've taken the little rock fragments, the clasts, and glued them together. Those individual pieces, we call those clasts, as in clastic sedimentary rocks. And here are the most common ones: conglomerate with gravel-sized grains that are round; breccia with gravel-sized grains that are angular; sandstone, where we have gritty sand grains, and usually a lot of quartz in these. And then we have shale. It's going to be not gritty at all, it's solidified mud, and it tends to be layered. And this thing here I haven't talked about, called mudstone, is just like a shale, except without the layering in it. On the other hand, if we have a bunch of sediment, like seashells, and we glue them together into a rock, what we would get is called a coquina. So this is our biogenic sedimentary rock, made of a bunch of shells that have been lithified and turned into rock. Biogenic sedimentary rocks would also include things like coal. You imagine we have a tree next to something like a swamp or a lagoon, and the tree falls into it and sinks to the bottom, and it doesn't decay. There's no oxygen, there's not a lot of circulation, there's nothing there to eat it. It just sort of rots and decays and is buried in the ground, and slowly over time the organic matter develops into this thing called coal. This is going to be the rock form of plant-rich organic sediment. And while we're here, usually coal is not going to come from animals, it's not going to be coming from dinosaurs, it's going to be made from plants. Think about trees. And for our final case, we have this lake bed, and it's very, very shallow, just a little bit of water, and there's a lot of salt, minerals, other things in it. The water evaporates and leaves behind all of this chemical sediment, which later lithifies and becomes chemical sedimentary rock. And this can include stuff like rock gypsum or halite, rock salt. It could also include things like limestone, where actually the main mineral here is something called calcite. So what happens whenever you take calcium, carbon, and oxygen, and you stick them together? Okay, so I know I told you this was going to be our final section. I lied. I'm sorry. We have one more. It's going to be on sedimentary structures, looking at things like this. What happens when you lay down sediment in interesting ways and settings? What are the patterns it forms? How do you explain a pattern like this, which is happening completely naturally? You gotta check it out.